So this final lecture will be only a few examples of what you can do in your final assignment, and also practical applications, things that you can do for the future with Python. I'm going to start with an example that Isabel gave me to process Word documents, then to see how we can create a web crawler with Python. Sometimes you need to gather data from websites that have several pages. So we'll see an example of this. Another thing is to process large files. By large files, I mean files that you cannot load into memory in one go, like we did so far. We use read lines or something like that, put everything in memory, and then process it. But we can also do it in pieces, and I'm going also to talk a bit about regular expressions, which is useful if you are dealing with text data and need to extract information from text. Then an example of processing images, just to show you some libraries that can help with segmentation, and how to use binary data files. During the course, we focused mostly on text files because they're easy to use. There were some exceptions like Excel files, but we had a specific module for that. But sometimes you get data from measuring device or something like that that is in some binary format, and you need to load it. So I'm going to give an example of this. I'm not going to detail too much this example, so I'll show you the code, but just go quickly over it, because this afternoon is mostly for you to get started with your assignment. But if there is something here that interests you particularly, just let me know, and I can focus a bit more on the details. So the first example, I thank Isabel for this example. The problem is that several people have to fill in these forms for proposals, for themes, for the master's topics, and then it's useful to automate the extraction of this data and put everything in a single file or in a table or something like that. So for this example, we're going to take information from several of these documents and then create just a text file with the title, abstract, and some fields from those files. These come in the Word document format, the docx format. So what we're going to do is we're going to take advantage of the fact that the docx file is simply a zip file with a lot of XML files inside that specify formatting and things like that. And one of those, which is in a folder called Word, and it's called documents.xml, so everything inside this archive, which is the docx file, this is the one that has the content of the Word file. And this is an XML file. It has some headers and lots of things, but then we can see by looking at this XML file that there are these tags, W:"T, that correspond to the text part. There are lots of other tags that correspond to data that Word uses for assigning language, formatting the text, and so on, but these are the ones that we care about. So we will first extract all the text from the Word document by extracting the characters between these tags. So this is what we're going to do here. We're going to import this zip file class from the zip file module, which is a Python class that lets us deal with zip archives. So we can simply create a new object of this class, giving the name of the file we want to read. So this is the docx file we want to read. And then we call the open method of this object. This works similarly to what we saw so far, opening files for reading. The thing is that when we call the open method of the archive, we must tell it which file inside of the archive we want to read. Other than that, it works the same as the open that we use for the file. The only difference is that we are accessing files inside the archive and not files that we have in our folder. So we read all the contents of the text. This is basically reading everything into a very long string. And now we close the zip archive. We don't need it anymore. And we're going to split this text on the end tag of the that separates the text. I use the end tag because sometimes the starting tag has some attributes and the text there can change. The ending tag is always the same. So I split everything on these tags here that occur after each piece of text. So now I have in these fragments a list of all the substrings of that XML file, all of those ending up to where this ending tag would begin. So the end of each of these strings is a part of the text of the document, and I want to join everything into a single string. So to do that, I have to look through all these fragments, all these frags here, and for each of them split it on this greater than sign, because this is the end of the last tag before the text, and retain the last fragment there. So because what I have here is fragments that were split on these tags. So I have things like all this text here up to this part. So I need to, from all this text here until this part, I need to find the final greater than sign and cut the text there. So this is what I do here, but instead of writing a for loop and looping through all the fragments, which is one way you could do it, I use a list comprehension like I showed this morning, because I want a list of all those parts of text, and so I don't need to write several lines of code to start with an empty list and then look through all the fragments and one by one do this. I just say that I want from some x the result of splitting with this greater than sign, and I want the final fragment from this split for all the x in this list of fragments. So this is an example of a list comprehension that will generate a list of all these parts of all the fragments. And now I can join everything into a single string, and I use the join method of a string object. The join method of a string object takes as an argument a list of strings and does the inverse of the split, puts them all together using whatever string you put here as a separator. So if you use a comma dot join some list, you get everything joined separated with a comma. If you use a space here, it's a space, or you can put anything that you want here. In this case, I use an empty string because I just want to glue everything together without any separation. Now, there is one final detail here that sometimes is tricky for when we're using text files that have characters that are not ASCII. So they have some markers like the tilde and things like that, and we need to convert those sequences of bytes into a Unicode string that can encode those kinds of that can include those kinds of characters. So since we read everything into this ASCII string that is basically a sequence of bytes, and we know that the XML document is encoded in UTF-8, this is one common encoding for these kinds of characters, we will create this string using this decode method of strings too, that will convert from those sequences of bytes, that is the standard string in Python 2.7, which is the ASCII string, into a Unicode string. And this way we can deal with all those strange characters. This sometimes is a bit tricky if you're working with this, because if you don't know the correct encoding, then things can go wrong and you get error messages, so sometimes you have to try different encoding. In the case of XML files, the encoding is usually indicating in the beginning of the XML file. So when you look at this document.xml file, you see the encoding there as UTF-8. So I knew that I had to use this one. And then I return the text. So I can test this. So basically, I run the function on this text.c. Then I print it, and I print the text, and I see this here. I just put those quotation markers there, so the syntax highlighting on the web page that I'm using here did not change all the colors here. So this is just a string with all the text. It's continuous, but with the text in the document. So now we extracted from all this confusing information inside the docx file, we extracted the text that is there. And now we need to extract the fields that the user filled in. We have some fixed text on our form, and then we have this part here, for example, up to a maximum of 15 words, and then here starts the title of the proposal. And it finishes when the next part of the text, of the fixed text, problema a abordar, and so on, starts. So we need to find these fixed text parts and extract whatever is between them in this text that we extract. And we're going to generalize this. We're going to write a function that can do this for any place in the text. We just need to specify what comes before, the prefix and the suffix, and it will take whatever is between the two. So this is what we're going to do here. This getFields function will get the text of the docx file, and then it will have to receive a dictionary that indicates the name of the field that we want, and for each of that entry in the dictionary it has two strings. The string of text that comes before the field that we want, and the string of text that comes immediately after. And for that field we want the text that is between these two, the prefix and the suffix. So we start with an empty dictionary where we're going to fill in the data with our fields. And for each key in this field dictionary, when we iterate over a dictionary, the variable here will have the key, each key of each entry of the dictionary. And so we obtain from that dictionary, for that key, for that particular field, we obtain what comes before and what goes after the part of text that we want. For example, we could give it something like this: words and the square brackets, and problema a abordar as the two endpoints of the text that we want, and put that in a key called title. And so this function would add an entry to the result dictionary, an entry with a key called title, and we'll put there the text that is between this part, words here, and problema a abordar, that part here. So we could extract the data. We should make these as specific as possible so that there are no confusions with different parts of the text, but this would be the idea how this would work. And then it will add all these fields to this result dictionary and return the result dictionary with the name of the field and the data that we want. The way we can retrieve part of a string between two known substrings, one way, intuitive way of doing this would be to split the string using the prefix and taking the second part, so what comes after that prefix, and then split it again on the suffix and take the part that comes before that suffix. So basically we retain what goes between the two substrings we have on each side. So this is how we can test this. We do call the getFields function, give it the name of the docx file that we want to extract information from, and give it this dictionary that tells the function that the title is between this string and this string here, the abstract is between this string and that string there, and so forth. Now, one detail here, I'm using, these are the standard Python 2 strings, which are ASCII strings. So I keep them like this. But with these ones, there are some things like descrição, for example, which has these strange characters. So I'm putting all of these strings as Unicode strings. That's why there is the U there before. So for the standard Python strings, each character corresponds to 1 byte. That is the standard ASCII encoding. For Unicode, it's more complex because in order to represent more than 256 characters, you need to encode some of them as more than 1 byte. So there is a special encoding for Unicode strings. But since we have these special characters and we had to decode the text that we read from the XML file, not as a standard Python 2 string, but as a Unicode string using this decode. In order to find the right matches, we also need to use Unicode strings here on the prefix and suffix. In this part, it's not necessary. We'll assume that our labels for the fields are simple ASCII strings, and we'll not use strange characters there. So now we have, as a result, this dictionary here that gives us for the abstract this Unicode string with the extracted from the large string with all the text, for the skill, for the title, and so on. And now we want to save everything to a file. So we can write this function, save to file, that receives a list of the keys that we want with the names of the fields that we want to save. So these are the keys for that dictionary. The dictionary, a list of dictionaries with all those fields, and then the name of the file that we want to write. So the idea is that we extract data from several docx files. We build a list with all of these dictionaries with the data for each of the fields, and then if we want to save some of these fields to a file for all the sources that we obtain data from, we can use this function. So this function opens a text file for writing, and then for each of those field dictionaries in this list, it will loop through the keys that we gave, so it keeps the ordering that is specified there, and we look for those fields in particular, and then it will write the name of the field, a new line, and then it will write the text that corresponds to that field. So this would be from the dictionary F will be the entry with that key. Now there is one problem here, that when we are dealing with these kinds of strings, that when we read from the file, we read a standard ASCII string, which needs to have several characters to represent some of those special characters, and we encoded it in the Unicode string, so that we can see the text properly. But now when we write back to a file, we need so we decoded it into the Unicode string, we now need to encode it back into the ASCII string to keep the original format and to save the file properly. Otherwise, we will get complaints from the write method that cannot write some characters. So we use this, we give the same encoding again, and so we will create a text file that is encoded in UTF-8. And this is what the result will be. And then after each document, we can add some marker to indicate that we're going to the next document. Alternatively, instead of adding new lines here, we can put something like tab and then create a table. It depends on what we want to do. But the idea is, now that we have the information, we are just putting the format that we want. So this is how we could use this script. We create a dictionary with the data that we want to extract, so the strings before and after in each case. We have a list of all the files that we want. Note that this list can be done by hand, or we can use glob to get a list of all the docx files in a folder, and then we can look through those. And then for each of those files, we append to this data list all the dictionaries that we get from the get field, with the result of extracting those fields from the docx file. And then we save our data to a file, and we specify which of those fields we want and what order we want them in. And this is what we get eventually, a file as we want. So another example, we need to crawl through a website. So this is one from one participant in the last edition that needed to extract these communiques from the government that are in this page that has entries for different governments, and then for each of those has entries for which of the categories you have, and then inside that it has the link for each press release, something like that. So in order to do that, we need to go through all these pages, starting from the top, and then crawl through the right links in this site. So what we can see here is that we need to click these links that say Ver Mais, so which have this class see all, in order to proceed for each of these sections. And we need to do that again here. So first we need to click this one, and then we need to click again on the same kind of link. And then here we have some different ones which have this class main for color, which is not very intuitive, but that's the name they gave it. And so we need first to look at how the site is structured and where we can find the links. And then we have also this problem that there are several pages for each part. When we go to these press releases or things like that, we have them organized in many pages. So we'll need to click through the pages too. And the idea is that we're going to create functions that can navigate these different pages. All these pages are different. The kinds of links that we want are different too. So we can write different functions for this, although they are more or less the same. We're going to use urllib2 to obtain the pages from the site. We're going to use Beautiful Soup to parse the HTML. So this is, for example, to get the links that say Ver Mais, all those links from one page where you have to click to see more information. We get we receive the URL for the page, we retrieve the page, and then parse it, and we look for all the links. The links are of this tag A for anchor, and we look for all these that have this class see all. And then for each of these, we check if there is comunicados, this keyword, in the text of the parent of the link. So the links that interest us are within some paragraph that has comunicados, and then comes the link. So we check for that, and we append the URL for that link into this list. This way we can retrieve all the links that interest us when we are in this page that we need to click Ver Mais. Then there are also the links for the pages. When we have this kind of things, that we have several pages, and we need to do basically something very similar, only in this case we are looking for a div that is a paginator, and then inside that div we need to find the links for the next page, and so forth. So what we're doing here is, after looking at the structure of the HTML page, we identify where we have to click to move to the next page, and we write the functions that retrieve those links that we would have to click if we were doing this manually. We do the same thing to retrieve each communique. So in this case, it's that main for color class we find there, and now we can process the page. We start with the base page. We get those Ver Mais links, and we follow the first one. And then we have to click again the Ver Mais link on that page. So after we follow the first one, we get the links for all the years, and then we proceed. We get the links for all the pages, and then we extend that with the links for all the communications, and then we retrieve that data from the communications. So basically what we have here is an automation of the task to click each of the page and then go back and then click again and so on until we follow the whole tree of the structure that has on that site. And we're going to append all the data, the title and the bodies of those communications into a large list, and then we can just export it all to a file. And so we put everything together starting on the first page, and then we process everything and we can write it to a file. So we get as a result something like this from crawling all those web pages. Then we have a single text file with all the information organized here. So another example was to parse large text files. In this case, it was a Twitter feed from the presidential election. So it was several gigabytes long, and it was not feasible to put everything in memory. So to do that part is very simple, because we can, when we open a file, instead of doing like this, that we have here, this is an example from the first week. We did this read lines and read everything into memory. What we can do is we're going to use the object that gives us access to the file, that open object. We're going to use it as an iteration. So if we open a file and we retain this object, we can then loop for each line in that file and read line by line. So we don't need to read everything in one go. If it's a text file, we can read each line at a time. And now we have in this large file, in the Twitter feed, each line is either a separator, which is a very short line with only a new line, or it is a JSON, that JavaScript object notation format, with a JSON record with the data on that particular tweet. So we have the ID of the tweet, the ID of the user, the text, and so on. And we need to obtain this data for each line of the text. We can do that by using this JSON library, which extracts the data that we want. And also, after we look at each tweet, we will need to do some statistical analysis as we go through the file. So we need to recognize some patterns in the text. And to that, we're going to use this library for regular expressions. I'll show you how we can do that. But let's start with this part here. We're going to we're going to count the different hashtags that we have in our feed. And we're going to list all the different hashtags and count their occurrence. So we start with a dictionary, an empty dictionary, where we're going to count the hashtags. We're going to open the file, but we're not going to read everything in one go. The file is too large for that. We're just going to iterate through each line on the file, and then we check if it's a long line, because there are some empty lines that separate those records. So if the line is long enough, we're going to use this JSON library here to read from the string the JSON record. And this one returns a dictionary with all these fields here. So created at, ID, and so on, all these are fields in the dictionary. And now we can look at this dictionary for the entities, and inside the entities dictionary for the hashtags. And this gives us the text corresponding to the hashtag in the tweet. For each of those, we extract the text from the hashtag, and then we have this way of counting everything. We can look for this text of the hashtag, so the actual hashtag inside our count dictionary, and if it's there, we're going to increment by 1 the value that we have there. If there is an error here, it means that the hashtag is not yet in the dictionary. This is a new one that we had not found before. So in that case, we add that entry to the dictionary and set the counter to 1. So whenever we find the hashtag for the first time, we put it in our dictionary with the counter set to 1. When it's already present in the dictionary, we increment the counter. This is a good way of counting things that you don't know from the start how many there will be and how many occurrences for each, but you can just try adding them to the dictionary. If they are not there, you capture the exception and put them in the dictionary. So this is now we can go through this large file with all those tweets, and we have a list of a dictionary with the text of each hashtag and the number of times it occurs in that file. And now we can also look at the text to try to extract some more information in a more sophisticated way. And if you're dealing with text, then learning regular expressions is a good idea. So I'm not going to go through this in much detail, but the idea here is that we're going to find 2 keywords that are separated by up to 6 words between them, between 1 and 6 words between the 2. And we can express this easily with regular expressions. We have these /b is a boundary between a word and a non-word. A word and a non-word are words are formed are groups of letters, and non-words are everything that are not letters. So spaces, numbers, things like that. So there must be a boundary here between non-word and a word, and then this word 1 is a fixed word that we give for the expression. Then we find here a non-word character that after this word, and then this group here inside parentheses is a group that we don't want to capture. That is, we don't want to keep. We want to find a match, but we don't want that returned. And what we don't want returned here is one or more word characters followed by one or more non-word characters, and this 1 to 6 times. So this can happen 1 to 6 times. These word characters followed by non-word characters are different words. So we have all the letters of one word, and then a space or a comma, something like that, then another word, and so forth. And this can happen up to 6 times, from 1 to 6 times. And then we have our second word, and it finishes there with a boundary to something else, either the end of the string or something that is not a word. So now we can use this to create this function that returns the ID and the text of all the tweets which have at most this between number between word 1 and word 2. So we can put in these parameters and ask for those that meet that criteria. So we're going to open the file, read each line, obtain the text of the tweet, and now we're going to create this pattern. This is basically this pattern here, but we're filling in the words that we get from our arguments, and also here we have the highest number of times, the most intermediate words that can occur, we put in this between value there. So we just create the regular expression for finding those tweets, and then we use the regular expression module to do a search there and check if it finds anything. So if it doesn't find anything, it returns none. If it returns something that is not none, then we found a tweet that's interesting. And we retain here in our dictionary, we put the identifier of the tweet and the text of the tweet, and then return that dictionary. And this is, for example, we could try to find Marcelo and Presidente separated by at most 10 words. All the tweets that have this ordering of text, where we have Marcelo and then up to 10 words and then Presidente. So we can find here, for example, Marcelo Rebelo de Sousa, Presidente. So these words, 3 words between the two, but it matches the criteria and so forth. So this is just a quick example, but if you need to deal with text data, this is very useful, because after learning regular expressions, you can easily specify what patterns you want to find. Another kind of problem that can occur is when you try to automate some task involving images. In this case, it's the problem of measuring the sizes of cells these are, I think, are plant cells in a microscope image. So we need first to identify the regions for the cells. And it's useful to automate this kind of task because doing it manually can introduce lots of errors that are difficult to reproduce, and then you have lots of variation between different people doing the same task and so forth. So what we're going to do is we're going to use this Scikit image toolbox with the package that has lots of modules for dealing with images. We're going to read our image as a grayscale, so we're going to combine, if the image is in color, we're going to combine the 3 color channels into one, because we're going to look only at brightness, and we're going to invert the image. So since this is now a floating point image, a floating point matrix with the brightness of the image, and it goes from 0 to 1, and since this is a NumPy matrix, we can easily do this kind of operation. So 1 minus the original image with just inverting black with white and inverting all the brightness. And then we're going to apply this filter, denoise bilateral filter. So this is basically a denoising filter that outputs the weighted average of the value at each pixel and the values in the neighborhood with a decaying weight given by a Gaussian that we can give the sigma value there, and also the weight we give to that Gaussian. So we're basically averaging around each pixel and changing slightly the value of the pixel depending on the average to reduce a bit the noise in the image. And then we're going to cut out parts of the image, keeping a frame here, and save that file. So this is what we get in the beginning, this is what we get at the end. You cannot see this very well here in the projection, but we have inverted the image, and now the cell membranes, the cell walls are in black. Now we can increase the contrast by throwing away everything between the 10th percentile and below the 10th percentile and above the 90th percentile. So we are shrinking the range here and then expanding it to increase the contrast. And we're going to rescale the intensity from 0 to 1 over what is left. So basically we're throwing away the outliers of the brightness distribution in our image and increasing the contrast in that 80% part of the image. Now we're going to use this filter to create a binary mask where we just say that each pixel is either black or white depending on an adaptive threshold. So this is not a fixed threshold for the whole image, because you can see that across the image is much darker on one side and brighter on the other. What we're doing is we're going to find a threshold in around 100 pixels at each point, and the average of the brightness there determines where the threshold is to make it fixed. So it changes smoothly along the image depending on how the average brightness changes. And then we can use algorithms like this, watershed for example, to start from these core regions of each cell, and then find where the different cells in the brightness of the image will meet. So this is called watershed because the algorithm works somewhat like filling water, all those basins with water, and then the boundary is where the two basins meet, the water meets between the two. So we get all these regions here. We can now easily remove everything that touches the border, because these regions that touch the border are either not complete or are distorted. We can do this by finding the labels of regions that are around the border and then setting those to 0 and discarding them. So this is what we get after the segmentation. We have in some cases we are picking several cells in the same region, but in many cases one region corresponds to one cell. And since cells are approximately have a well-defined range of sizes, we can easily automate discarding those that are incorrectly segmented and at least find those that are correctly segmented, and then we can measure the statistics on those, the area, the perimeter, and so forth. Another problem that sometimes we have is to read data that is not in text files. So sometimes you have data from devices, something like that is in a binary file. And in this case we have data from the NASA Shuttle Radar Topography mission, which gives us some matrices of 1201 by 1201 pixels or cells, which give the altitude of the ground in each of that cell. So we're going to, these are binary files, they are not in text, so each altitude is a 16-bit integer, and they all come in a row in a file. So we need first to read that file. We need to know the format. In this case, it's a big endian format, which means that the 2 bytes that make up each of these altitude values, the most significant one comes first, and then comes the second one. So basically, the first one, each number there is worth 256 times the number that is there, and then we add the value on the second byte. But we can do this easily with NumPy, so we're going to create a matrix from this file, and we're going to create a vector first from the file. where we give the number of the name of the file, and then we indicate what is the data type there. And this is an integer with 2 bytes, and the big end comes first. We can compose this code here, and you can see the documentation from there. And we also say how many records of this type we have in the file, so it's 1201 by 1201. And now we take this long string of integers, so this long array of integers, this is a vector, because all the data in the file is sequential, there is no matrix there in the file, but we're going to reshape it into a matrix with the right number of rows and columns, and we're going to convert it to a floating point matrix. And now we're going to throw away everything that is below 0. So everything that is below 0, probably an error or mismeasurement, something like that, we're going to set it to 0. Now we're going to plot in 3 dimensions the data that we have here. So what we need to do for the 3D plot, we're going to plot, to import those 3D axes. We need to know the correspondence to which cell, which matrix we're going to look at. But I chose one over Lisbon, so I'm going to plot the degrees, latitude and longitude on the chart. And then what we need to do to do the 3D plot, if you already did this in MATLAB or something like that, this is very similar, but basically we need 2 matrices for the x and the y, which are created by this mesh grid, because for each, if we superpose the 2 of them, for each point in this xy plane, we have the pair of values x and y. And then we're going to plot z as a function of those pairs of values. But we can easily do that by first creating the 2 axes, x and y, and then using mesh grid to create these 2 matrices. And now we're going to do a surface plot with the height matrix and those 2 x and y matrices that we obtained for mesh grid, and we can set the z limit to adjust the scale of the height, and we get this result. So this is Costa de Caparica, this is Tejo here, this is Sintra, the mountains there, and we are plotting the altimetry data for this square around Lisbon, which is here. So this is just an example not only of the 3D plot, but also how you can read data that is in a binary file. As long as you know the format, it's easy to process that data. Okay, so that's it for my part. I'm done talking in this course. So now it's up to you. We're going to the ideal thing would be to try to advance as much as possible on your final assignment today. And then during the week, if you have questions, you can contact me by email or even Skype if you need to discuss anything. Okay.